All right, so it's a likelihood of an event happening and is expressed as a number between 1 and 0. Now, when I'm doing 0 and 1, all right, I am doing it in terms of percentages. So if I have 0, it would be 0%. Okay, so if I had 1, what do you think my percent would be? 1%? If you have 100% of something, if I had 100% of a pizza, I have one whole pizza, right? So this 1 would represent 100%. So what do you think 1/2 would be? Yeah, 50%. Okay, so it says label the terms on the number line. Unlikely, equally likely, impossible, certain, and likely. So if I had a 0% chance of something happening, what word goes with 0%?
Impossible.
Impossible. Okay, so if I had 100%, there was a 100% chance it was going to happen.
Unlikely.
Likely.
Possible.
Certain.
Oh,
I forgot to translate, but you can go make a. Will you make like 10 of them?
Yes, ma'am.
Thank you. Okay, so then if I'm about here, do you think that's in between impossible and 50%?
yes.
Okay, so what percent range do you think that would be?
Unlikely.
20 to 30.
Oh.
Okay, let's think about this in quarters. 25, all right? So this would be,
75.
okay, so if I'm at 50%, if I had a 50% chance of it happening, what term do you think would go with that? Equally likely. So if I flip a coin, am I equally likely to flip heads as I am tails? Yes.
Well, fine.
No. Yes. Okay, 25%. Am I likely or unlikely for it to happen?
Unlikely.
It's still pretty unlikely. But is it impossible? No, but the odds are more than likely not going to happen.
We're going to use like a lot.
Okay, likely would go with 75%. Ooh, you do got all kinds of colors.
I had yellow, but I don't wear it.
I don't like yellow. It's fine.
I might have. But again, I might have used it on something.
Okay. Okay. So it says read each example and label the situation with one of the terms above. When it says one of the terms, we're going to use impossible, unlikely, equally likely, likely, and certain. So what are my chances of getting wet if I jump into a pool?
Certain.
Certain. If I jump into a pool, it is certain I'm going to get wet.
That's common sense.
Nope. No what ifs. No what ifs. No what ifs. Burning your dinner if you cook it too long.
Certain. Likely.
Likely. Because if you cook something too long, does all of it burn?
No.
No, not all foods will burn, but now some of it can just be overcooked if I cook it too long, but it doesn't always mean it's going to burn. Okay, water boiling at 75 degrees Fahrenheit.
Unlikely.
Impossible. Anybody know the boiling temperature of water?
100.
100 degrees Celsius. But I think it's 212 degrees Fahrenheit. So is there any way it would, guys, think about 75 degrees outside. That's a nice fall or spring day. Do you think water is going to boil at that temperature? No. Thank you, sir. Thank you. Okay. Getting a ticket if you are speeding.
Likely.
Likely. Why is it not certain?
Because there's not cops.
Sometimes cops.
They can let you off with a warning. Is a cop there every time you speed? No. Okay.
What is that called?
Scoring 2 points on a safety in football.
Likely. Certain. Pretty much
Unlikely.
Unlikely.
It's like a 50-50 chance.
Put unlikely. And Ryder had a good reason behind why it's unlikely. Coach, do you have a good explanation on why that would be unlikely?
Scoring 2 points on a safety,
On a safety, yeah.
you have to be tackling the end zone.
hmm
It's not unlikely.
It's more unlikely.
Yeah, they're not going to throw the ball in that close.
It's not
Well, I don't know. I
impossible,
would
but it's
so.
not
I don't know.
Ryder explained it really, really well to
Tell me
where
what
it went,
Ryder
and I
said.
don't know exactly, I can't remember exactly what he said.
But I don't think it would be equal.
Because him and Curry were debating it because one of them, this is what made our biggest difference on a safety.
But if there is a safety, it's guaranteed you're going to score the 2. Well, no, it's not.
Because the other team gets.
See? That's not the best example.
Score 2 points on a safety. If you get a safety, you will score 2
Yeah.
points.
If you do, but
Because they don't count it as a touchdown.
But it doesn't say if they score safety. It says on a safety.
it says on a safety, and then, but you've got to think of all of your things. Unlikely, you still have a 25% chance of doing it,
Yeah. But not.
but are those harder to get than a field goal?
Yeah.
Most of the time, because don't they? Yeah.
Pretty much sometimes you have to do it.
Again, not the best example, but we're just going to move on. A coin landing on heads when it's flipped. Equally likely. Why is it equally likely?
50-50 chance.
The 50 chance.
Turn around. Hey,
Boys. Okay. Guys, let me just tell you right now. This topic is very, very frequently tested on the STAR test. Okay, so when I say that this is very important to make sure that you are understanding and very important to ask questions, it is very important. They test the most on this topic the last couple years on the STAR test, okay? This is a STAR test question. So it says, which statement about the flavor of potato chips chosen is best supported by the information in this table? Okay. The flavor is least likely to be plain. Is plain the smallest number there? So do you think it's the least likely to be chosen? No. Which one would be least likely? Ranch. Okay, so that's not true. The flavor is twice as likely to be jalapeno as ranch. Well, if I do 8 times 2, does that give me 18? No. The flavor is equally likely to be plain, jalapeno, ranch, or cheese. Do all of them have the same number? No. The flavor is more than twice as likely to be cheese as it is ranch. So if I did ranch, that gives me 16. Well, is that more than twice?
Yeah.
Yes. Not too bad? Okay. Do you think all probability is going to stay that easy? No. Okay. Rebecca is going to randomly choose a cookie from a box. There are 7 sugar, 16 chocolate chip, 4 peanut butter, and 3 snickerdoodle cookies. Write 2 statements comparing the probability using the terms from the number line above. Let's come up with a statement like one of these. Okay? Somebody come up with an example.
Flavors, numbers bad. I mean, numbers of cookies.
Okay, we're trying to come up with a statement like one of these.
Oh. I got nothing. The flavor is probably least likely to be snickerdoodle.
Okay, so snickerdoodle is least likely to be chosen. Why? Because it has the least amount of cookies. Okay, so let's think of one kind of like the example that we chose. Because there's one, it would work maybe more than, it's not necessarily twice, but. Okay.
chocolate is the most likely.
That would be one. What would the comparison be between chocolate and peanut butter? Four times.
Chocolate is 4 times more likely to be chosen than peanut butter.
Good. So chocolate chip is 4 times more likely to be chosen than peanut butter. Y'all agree?
Yeah.
Once you got it, flip it over. We're going to kind of zoom through the back so we can get to the next part. And the back's not too bad.
Oh, we're doing 2 lessons today?
Yes, because tomorrow I'll be out with the picture retakes. So y'all are just going to work on, y'all won't have homework tonight. You're welcome. You'll just do the homework assignments for these 2 lessons in class tomorrow.
But guys, make sure you keep your notes. I know that I was helping a
Go-
bunch of you work on your folders, like when we were going back and reworking on work that you had to make up. And you didn't keep your notes, and I was so.
Guys, you will need your notes for tomorrow. You won't be able to do this without your notes. Okay, so we have simple probability and its complement. So the simple probability is the ratio of successful outcomes to total number of outcomes. Okay. A ratio is a comparison of 2 things, right? So I'm comparing the successful outcomes to total number of outcomes. So this is our formula for finding simple probability. What it means, okay, the A is asked for. So if it asked for chocolate chip, okay, what is the probability of choosing a chocolate chip cookie? You would have put, well, it had 16, right? So I would have put 16 on top, and the bottom would be your total number. So total outcomes. Okay. The probability of an event not happening or not occurring is the complement. The probability of an event and its complement have a sum of 1. So if the simple probability of choosing something was 1/4, what would this have to be to add up to 1 whole? What, Hartley? 3. Because 1/4 plus 3/4, doesn't that give me 4 out of 4? Is that 1 whole? Yes. Okay, so if my simple probability was 50%, what would this have to be? What do I add to 50 to get to 1 whole? 50. Okay. So the formula for this one, so is not asked for over total. So if 16 chocolate chip cookies were asked for, I would add up all the other ones that weren't chocolate chip. Okay.
Okay.
Okay, so it says, what is the probability of choosing a marble with stripes? Well, how many marbles do I have with stripes?
2.
2. Okay. How many are there total? What?
6.
So there's 6 total. I want y'all to get in the habit of doing that too. So if I know that my total is always going to be on the bottom, so I have 2 out of 6. Can that be reduced?
Yes.
To what?
By 1/3.
To 1/3. Okay, now the sparkles one, you got to kind of look closely. A few of them have like those little dots on them. How many have the dots or sparkles?
4.
3. These 3. Okay, so 3 out of 6. Well, that's equal to what?
1/2.
1/2. Okay, so number 10, it says, what is the probability of spinning a heart? Well, what do I need to know first? What's my total?
7.
1, 2, 3, 4, 5, 6, 7. So 7 total. Well, how many are hearts?
2.
So I have 2 out of 7. Can sevenths be reduced?
No.
Okay. Now the second question says, what is the complement of spinning a diamond? Okay. Well, how many diamonds are there?
4.
So if 4/7 was the probability of spinning a diamond, what is the complement to that? What would make that add to 7 out of 7?
3.
So 3/7. Does that make sense?
Yes, ma'am.
But what is the opposite of it pretty much to add up to one whole? Okay. So number 11. Guys, even on a STAR test question, it calls it this. A standard number cube. What do you think that is? What is that? That's just a dice. Is rolled. What is the probability of rolling? First of all, how many sides are on a dice?
6.
So I have 6 total. All right. So what is the probability of rolling a 6? Well, how many 6s are on a dice? 1. So I have 1 6.
Well, it depends on how many dice you have.
Well, it says a standard number cube. So if I have a, that means 1. Okay. How many odd numbers are on a dice?
3.
3. So 3 out of 6
1/2.
or 1/2. Okay, a laundry basket contained 24 socks. 6 were navy, 10 were black, the remaining were white. What is the probability of drawing? Okay, how many did I have total?
24.
24. Okay, well, how many were black?
10.
Can 10 out of 24 be reduced?
No.
What? Those are both even numbers if they're even. Okay, if I divide by 2, well, what's 10 divided by 2? 24 divided by 2 is 12. Could 5/12 be reduced? No. Okay, so does it give me the number of white socks?
No.
What does it say? The remaining. Okay, how many were remaining? Okay, so I had 10 and I had 6, so that's 16. So I have to do 24
8.
minus 16, which gives me 8. So 8 out of 24, what can that be reduced to?
3 12.
3/12 can be reduced down to 1/3. If I divided by 8, 8 divided by 8 would give me 1. 24 divided by 8 would give me 3. Okay, we gotta move a little bit quicker. The spinner below is spun. What is the probability of spinning? So not a 6. Well, how many are there total?
1.
7. Okay, so if I have not a 6, well, how many options are there for not a 6?
5. 6.
6. So 6/7. Okay, so if I took 3 and 4 away. Oh wait, it says a 3 or a 4. Well, there's only one of each, right? So what would that be?
6 7.
I have 7 total. Only 2 of them match what I would need, so 2/7. Okay, how many odd numbers are there? 3. 4. 1, 3, 5, and 7. Doing okay? Sure? Okay, it says the letters in the word soccer. Well, how many letters are there?
6.
Okay. So it says, what is the probability of choosing a vowel? Well, how many vowels are there?
2.
2 6 is the same as what? 1/3. Okay, how many consonants?
4.
What does that reduce to?
2/3.
Okay, the letter C. How many C's are there?
1/3. Easy.
Okay. The probability of selecting a nonfiction book off the return shelf at the library is 1/3. Describe what 2/3 would represent. What do you think 2/3 represents if 1/3 is nonfiction? So it represents the probability
2/3 represents the other books.
of selecting. What are the other genres of books? I heard somebody say it. Selecting a fiction book off the return shelf. Not too bad. Ooh. and then bring y'all another paper. We aren't going to get through all of it, but we're going to do a few examples.
Do we put this other one in our?
You can, or you can keep it out. It may help you. Guys, since I put that weekly up there, and I know y'all do planner grades for Miss Garcia, right? No, or Munch. Do y'all have Garcia? Okay. So, would it be a good idea if you already have to do that to write that down in your planner so that you know what's coming up?
Oh, are we gonna do another one of those calendars?
Yes, as soon as I finish it, because I'm making a few changes to it. All right, so the paper in front of you. Do you want to go make? I
Yes.
forgot I was doing two.
How many do you want me?
You can do 10 again.
Okay.
All right. So I looked and looked and looked at this yesterday, and I was like, is this really necessary for me to teach, or can I skip it?
Skip it.
Guys, if I gave it to you, do you think we should skip it? No. I looked at Star Test, and I was trying to see if it was tested this way, and it is. There is one that asked what sample space represents this probability. Okay? So, it's going to seem ugh, but it's not that bad. Some of you, if you are visual and you like to see things, this is going to help. Okay. So, when we have a sample space, we're thinking of diagrams, pictures, something that can show me what all my possible outcomes are. Okay. So right here it says a school uniform requires students to choose from a blue, green, or white polo shirt, or khaki or navy shorts. Okay, so it says a polo, so that's a shirt, is randomly selected from a drawer with one of each color. Record the options in a list below. So if I selected a shirt, what 3 options were possible?
Blue, green, and white.
Blue, green, and white. Okay, if I selected a pair of shorts, what were my options?
Khaki or navy. I should do that. Oh, I don't know.
Okay, but this is saying at random, not what you prefer.
That's a weird one.
Okay. So it says use the tree diagram below to show the 2 events and the total possible outcomes when selecting a polo and a pair of shorts. Okay. So if I selected a polo, I have blue, green, and white. Okay. So what were my 2 options for shorts with the blue polo?
Khaki.
Okay. Do y'all agree that that is my option every single time? Those are my options every time. No biggie.
My bad.
No biggie.
Okay.
Okay. So it says list the total possible outcomes when selecting a polo and a pair of shorts. How many possible outcomes? This was interesting. I got all kinds of answers last class period. How many possible outcomes do you think I have?
3.
Okay. Anybody else think more?
6.
Okay. Why 6?
Because there's blue, khaki, blue and navy, green and khaki, green and navy.
That's exactly right. Okay. Because this one was 1 option.
Oh.
This one was 2. So this would be my 3rd. This would be my 4th, my 5th, and my 6th. Okay, so I'd have 6 possible outcomes. And if you think about this, how many shirts did I have? 3. How many shorts? 3 times 2 give me 6. So it says use the tree diagram or list to determine the probability of selecting a blue polo with khaki shorts. Well, that was one option. How many did I have? 6. So what would my probability be? 1 out of 6. Good. Hey, Coach, can you up that thermostat a degree or two? It's cold. I'm cold. Are y'all not cold?
No.
I'm usually hot and y'all are usually cold. Okay. So a sample space describes all the possible outcomes of an event. Sample space can be displayed using a list or tree diagram to determine the probability of simple or compound events. Okay, so simple was the probability of what was asked, right? Compound or the complement or the opposite. All right, so it says use your understanding of lists and tree diagrams. We're going to kind of use a tree diagram, not a list. All right, for this next one. So a fair coin is tossed 3 times. Fair coin, that means you either get heads or tails, right?
Yes.
Okay, so my first toss, what are my options?
Head, tails,
Okay, so if I tossed it once, I could either have heads
tails.
or I could either have tails, right? Right? Okay, so this is representing my first flip, my first toss, right? So right away I have 2 options, yes? Okay, so if I flipped it again, do I still have 2 options?
Yes.
Okay, so this would be my second flip. I would have the same options if I would have had tails, right? Well, how many tosses or flips did I have to do? 3. So what do you think I would do from the heads and the tails? Because I have to toss it one more time. Well, if I tossed a heads, what are my possibilities for my third flip? Heads or tails, right? What if I would have flipped a tails? Do I still have the same amount of possibilities after that? Yes. Should I do the same thing over here? Okay. So these were my third flip. This is how many total outcomes are possible. I just want to see what y'all think.
How many possible?
How many possible outcomes?
2.
Guys, I flipped 3 times.
Oh, 6. 12.
12.
12.
It's 12.
Oh yeah, it's 2 times 6 is 12.
So I've heard 6, I've heard 12. Any other guesses? Okay. Nobody said the right answer. Okay,
14.
so here's 1, right? Here's 2. So here's 1, here's 2. So that alone is 4, right? So this is 5. This is 6. This is 7. This is 8. Okay, on my first flip, how many outcomes did I have possible? 2. And then I had another, right? Because every time I flipped a coin, how many outcomes were there? 2. I had heads or tails, right? And I flipped 3 times, so I had 2 times 2 times 2. Well, 2 times 2 is 4 times 2 is 8. We still have 4 minutes, so just because y'all see them, don't do anything. I want to get through one more. So flip it over. Okay.